You know that baby that was like on Saturday? Why does he look like he's pregnant? That's the name he saw? The tall one with all blue? Yeah. Why is there I'm pregnant?
Because he's trying to get your attention. He's trying to get your attention. You're a girl, he's a boy. He's nervous, he doesn't know how to talk. It doesn't matter. He's trying to get the boy's attention. He gets your attention. He gets you to say he's funny, he's nice. Then you tell the boys. The boys, some boy who's gay hears it. Maybe he gets a date. That boys are. What are you talking about? That's how boys think. Okay. What do you want me to say? Okay. I'm telling you.
I feel like you didn't come yesterday because you knew all teachers had to go to the prep rally. I feel like that's why you didn't come.
First of all, I don't go to pep rally. I sit back and I sit in here. So I love staying because I get. They said all teachers. No, they said that because teachers weren't going. But that normally teachers go. I usually stay behind. But I did not come because I had to be for my own reasons. Are you going to homecoming?
Yep.
I think it's a good idea.
And I don't want to retake my test now. Is that something I can do about the other than taking tests?
The quiz, you mean?
Yeah.
Yeah, you can do that. Can you hold on? I'm in the middle of something. What'd you say?
Can I use the rest?
Yeah. I don't know what was going on the first 5 minutes. I'll have to edit it, but we'll go on. I'm not redrawing this, I'll tell you that. So when you look at this, this would be a drawing, a way of drawing an atom. You've seen atoms drawn, I'm sure, that look something like this, where they... Have you seen that to represent an atom, right? Really? Never seen that kind of drawing where they draw like that's supposed to be an atom? All right. The reason they draw that is the things at the very center are all the protons. They're all the protons in that atom are in the center. And those protons, they throw out a little bit of a force. It's not a little force, it's a force, and it pulls on the opposite charges. And as it pulls on them towards the center, towards them, it's pulling them into the center, into the nucleus. The reason that they never reach the nucleus is because when they get close to each other, when an electron gets close to an electron, what do? They what? They have another force that does what? What do the electrons do to each other? What did like charges do? No. So let's get that straight. So that's good that we said that. I'm glad you said it now. Thank you. Thank you for saying it. So let's remember, opposites attract. We have to get that straight. That's going to be very important. If you confuse that, you're going to get confused. Opposites attract. Like charges repel. And you know that if you take a second and think about a magnet, you put two negative sides of a magnet together, they're going to push away. Correct? And if you put a positive and negative together, what do they do of a magnet? They attract. So you get the attraction between the nucleus, which is really tiny in the center of the atom, and then it's attracting these electrons. They come whizzing at towards the nucleus. As soon as they get close enough, they start bumping into other electrons, and those fields, they have a force field. Do the magnets, when you played with magnets, everyone's played with magnets, correct? Yes? Or at least have handled them. If you handled a magnet and you try to push two ends together, do they ever touch without you actually putting a lot of force to them? A strong magnet, you feel the force before they even come close to each other, right? Use a lot of gap. And then when they attract, they start pulling at each other from a fair distance. And you've seen the giant magnets that they pick up cars. They'll go down, they'll just get close to the car, and the car will go right up. And in movies, you see that kind of stuff, right? Where giant magnets pull people across rooms and that kind of thing, right? Well, these magnetic forces are strong, and when these electrons get near each other, they push away. So they have to come to some balance. They keep getting pulled by the nucleus, but pushed away by each other. Two opposite forces. And what you end up with is an orbit. An orbit. All right? But there's tiny orbits, and they're not consistent. They're not like the planets. The planets and the moon, we know where the moon's going to be every minute. If you just do some calculations, I can tell you where the moon is. There's apps that follow the moon around. They don't actually follow it. They just calculate it. You can calculate where the moon's going to be. Where's the sun going to be? Where's this star going to be? Where's that star going to be? Because they're consistent in their movements. Electrons are not. Electrons, we can't predict exactly where they're going to be. But we can predict an area where they can be. An area. We call these areas of probability. We've talked about probability already. So areas of probability we call those orbitals. Like an orbit, but not quite. It's probably in there. 90% of the time it's in there. The electron's in here somewhere, but we're not sure where. That's why you'll see a lot of drawings of atoms, instead of that, this is what they draw. It's really hard drawing to do, so. It's a cloud. We call it the electron cloud. Yeah, that was a joke, but it went south. So, an electron cloud. That's really what a more accurate drawing of what the outside of an atom would look like. Not this, because they don't do consistent orbits. They do this like it's somewhere in there. Now, this would be a carbon atom. If I take real close at the nucleus, this is what would be in the nucleus. I would find 6 protons and 6 neutrons. Now, neutrons have no charge, but the protons are attracting. What are they attracting? And what's the opposite of a positive? Negative. And what is that negative particle that you should have memorized for the quiz? An electron. Neutrons are 0 charge. It's an electron. So an electron gets pulled in, and they get here to the first shell. This is called the first shell. The first shell, the electron gets pulled in. There it is. There's an electron. And it needs 6 electrons to be 0 charge, right? Remember, it needs to be 0 charge. Remember our 2 rules? You got quizzed on it yesterday, correct? All right, you had 2 rules. Well, the first rule is that atoms tend to move toward being neutral. They do all they can to be neutral. All right? And then the second rule is they want a full octet. Octet means 8 because the outer shell, and that means the full outer shell. That means the valence shell, the outer shell. They want it full. That's it. And usually that's 8. You're about to see it. We're about to count them. And now then the next step is the second half of today. I want you to actually build them with models. You're going to build atoms with models and then make connections between, not atoms, but build molecules. All right, I have some model kits that Mr. Dugan so kindly lent us. So we're going to be very careful because they're very expensive. Okay? Yes? Mm-hmm. All right, yes?
What did that B word say?
Valence. The word is valence. It means outer shell. So whenever you hear, you're going to hear that word for the next 3-4 years. And if you go to college, you'll hear even more. Valence shell is the outer shell of an electron, of an atom. The outer shell of an atom where the electrons exist. These are areas of probability. They do not actually exist. They're not roads on the ground. They're not hallways in a building. They're paths. If there's no electron, they don't exist. Does that make sense? It's empty space. But we're saying the yellow, what you see in yellow, is an area where we're likely to find electrons. Is that clear to everybody? I don't want you to think like an atom looks like this all the time. It doesn't. If those yellow areas don't have electrons because the atom doesn't have enough positives to pull in electrons, the yellow doesn't exist. Is that clear? So it could have up to 4 or 5 shells, but if an atom only has 6 electrons, it's only going to have 2 shells. It's not going to have 4 or 5 because it doesn't have enough positives to pull in the electrons. You have to be clear on this because I'm not going to be able to go back. We have to move forward here. So there's 1 electron. So how many do I have to pull in to make this neutral? 6. So I have 1 in. Second one comes in, and every time this electron moves this way, what's this one going to do? Move that way. They're going to just keep going around in circles. We call this a sphere, like a basketball or a baseball, a sphere. Okay? So this first shell, the first shell only has room for an S, for a sphere. A sphere is very compact. It takes up a lot less space than the dumbbell. Have you ever seen a dumbbell? The things you lift up like this, they're called dumbbells. All right. Or you lift weights like this, it's a dumbbell. All right. So we need, how many more? We have 2 now. We need 4 more. So another electron gets pulled in. Again, this is a constant force. That's, how many more? How many more electrons? 3. So another one. Now, the s orbitals can only hold 2 electrons. S orbitals can only hold 2 electrons. This shape is only enough room for 2 electrons. If you're going to put more than 2 electrons, they gotta go further out. They have to take up more space because they push each other away. Not only are they pushing each other away, but these 2 are also pushing away. Everything, all the negatives are all pushing away from each other in every direction. This is 3-dimensional space. Does everybody recognize that this is a 3-dimensional space? Everybody know what X, Y, and Z is? Have you heard of Z before? It's what's going in and out of the board. So Z would be coming out of the board and into the board. 3-dimensional space, 3D. X, Y, that's 2D, right? 2 dimensions. The third dimension is in and out of the board. Depth. Length, width, and depth. You've never seen the z-axis? Okay. Ask your math teacher. There is a third axis called the z-axis, and that's called depth. Z axis. There's the x-axis, there's a y-axis, and there's a z-axis. Axes, more than one. Axes, not axes. Axes is chopping down wood. Axes with an IS. I don't know. Whatever. Call it what you want. The bottom line is there's 3 of them. Are we good? Are we good? Or I don't want to keep going, and then we get to the end, and you're like, I don't know what's going on. Yeah. All right. All right. We're good. All right. So we got 4. Now we got to put how many more to make it neutral? 2 more. But they don't fit in the. By the way, this is the second shell. This is the second shell. And this here, where these are the 2s. These out here that look like dumbbells is badly drawn, I know, but deal with it. They're dumbbells, right? They're called p orbitals. These are the p orbitals. There's 3 of them. There's one on the x, one on the y, and one on the z. Each orbital can hold 2 electrons. So the p orbital, the whole thing's called an orbital, but there's 3 sets, the x, the y, and the z. So we need 2 more. So we just fill in 1 here and 1 here. It could go on the x, but I'm just going to put on the z and the y. So the outer shell is the second shell. Does everybody agree? In this electron, the outer shell is the second shell. Is this shell full? It can hold 1, 2, 3, 4. It can hold 1 electron in each direction. So 1, 2, 3, 4, 5, 6. It can hold 6 in the p orbitals. It has how many? 2. Is it full? No, it's not. How many does it need to be full? 1, 2, 3, 4. Correct? It needs 4 to be full. Okay. I hope you understood that. If you didn't, I hope you watch the video again, because you really need to understand it because of what I'm about to say. So the outer shell, is it neutral? Yes. You counted with me. There were 6 protons and 6 electrons. That equals 0 charge. Everybody agrees that this atom that I just drew is neutral. This atom is the element carbon. How do I know that? It has 6 protons. It is carbon because the proton number defines the element. Are we good? You were just tested on that. All right, very good. So having six protons and 6 electrons, that's fine. But now we need 4 more electrons. How do we get them? We can't. The carbon doesn't have any more positives to pull any more electrons out. It's neutral. So it's not pulling anything, right? Every positive has its electron. It's neutral, so it's not pulling anymore. How does it balance out? Rule number 2. Bonding rule number 2. You have to balance out these 2 rules. How do we balance this rule out? Can't you tell me? You should know, even though I never directly told you in this situation. How do we balance it? It needs the second rule filled. It can't pull any more electrons in. What can you do? Huh? I can't hear you. Add protons. What a good idea. That would work. But then if I add a proton, what do I do? Is it carbon anymore? No. You could add protons, but then it's not carbon anymore. How can carbon stay carbon and still have another 4 electrons? So let's think about it. You have $50. I want to say your sister or your brother, but sisters and brothers don't do well with each other when it comes to sharing. So let's say your boyfriend or your husband has $50 and you have $50 and you want to buy a house that costs $100. It's pretend money, so let's just deal with it. What are you going to do? There's no way you can get another $50. What are you going to do? Huh? Combine, share. You're going to share. So that you two together have $100. And what do we call it when atoms share electrons? Bonds. So that's why they make bonds. So they can share electrons and fill that outer shell. Does that make sense? The real reason is it lowers the energy that, right now, this is a high energy atom. It takes a lot for those electrons to stay. It's not stable. It's like putting your washing machine on spin cycle with one pillow. What happens? You ever put your washing machine, do you wash clothes? Well, I mean, some people don't wash clothes because their parents do. I'm not saying people don't wash their clothes. You wash clothes? Have you ever had the machine go insane? The washing machine go insane? That's never happened to you? Oh, you're lucky. It has? Okay, all right, Miss Judgmental. All right, Miss Argumentative. I know, I am Mr. Argumentative. I said that 1,000,000 times. I don't understand. Nobody listens to me. So, my other mic, where is it? Huh? They ran away from me? Mm-hmm. Come on, guys. I'm trying to make a point. I'm not. Listen. You got a machine that's not balanced, a washing machine that's not balanced. It's going to start going insane, right? High energy. Do you agree? Yes or no?
Yeah.
So the outer shell has to be filled or it won't be balanced, and the atom it requires a lot of energy. It's going to be very reactive. So it needs to find those electrons to bond with. Think about you need $50 to eat. You need $100 to eat. You only have $50. You are very, very motivated to share $50 with someone else so you guys can eat together. Correct? No? I feel like Kindergarten Cop so many times. So, have you ever seen that movie, Kindergarten Cop?
Oh, I seen that movie was so good.
Do you remember when the kids were like, the little kid was like, maybe you have a tumor. Maybe you have a tumor. I don't have a tumor. That's not the point. The kid, those kids are very literal. That's what I'm dealing with here. Stop being so literal. Of course, you're not going to need, if you have $50, you can buy your own food. I get it. Think about a situation where if you have $50, but you need $100 to eat, you're going to be very actively looking for someone to share that has another $50, so you can share the money to get the food so that you can eat. Correct? Right. Very motivated. It's a great movie, though, right? All right. So, in any case, what happens is carbon can make 4 bonds. Why is it going to share 4 bonds? Why is carbon sharing 4 bonds?
Because we ran out of
Electrons. And how many electrons do we need to fill the outer shell? 4. So we need one here, we need one here, we need one here, and we need one here. If we fill in those 4, then the atom can be more stable. It can calm down. Is that clear? Yeah. Okay. So now, let's go look at those 4 So here's this carbon. It has 6 electrons, so I'm going to put 6 little plus charges right here. That looks weird, so I'm not going to do that. 6 plus. So now, it has 4. So it needs 4. You know what? I'm just going to erase it. It needs 4. So I'm going to put how many electrons I have in the outer shell. This is an easy. See how much drawing it took to do this? Do you want me to make you draw them all out like this?
No.
So then learn. If you don't want that, then learn how to draw it this way. This is called a Lewis dot structure. It's real simple. You're either going to draw it. You're either going to draw it the way I just drew it, or you're going to do it the way I'm doing it right now. Here's a simple way of doing it. So learn it now and make peace with it. So I can take a periodic table. As soon as I find my periodic table. And if I look at the top of the periodic table, now hear me clearly, because if some of you are going to forget this and you're going to say you never heard it or whatever, you cannot do this with these. So don't do it with those. Those are called transition elements. So what I'm about to tell you, do not do it with those elements. You'll do this in chemistry a lot. Next year, you're going to be doing this a lot. Do not use this method with the transition elements. With all the other ones, which are the ones we really are worried about in biology, right? Hydrogen, carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, correct? With all the rest, you can look at the group number, and the group number tells you the number of electrons in the outer shell. It tells you how many electrons. If the atom is neutral, this is the number of electrons in the outer shell. Are we hearing me? Yeah. So here is one. Oh. So in the first column, every one in this column has 1 electron in the outer shell. This one has 2 electrons in the outer shell. I'm going to skip the transition elements. This one, the third, 3 electrons in the outer shell. So I'm looking at the ones place, 4 electrons in the outer shell, 5, 6, 7, 8. 8 is where they want to get. So these here have no charge. These elements here have no charge. The purple ones have no charge. And they have a full octet. They have no reason to bond. They're not reactive at all. They're highfalutin. They're royalty. So we call them noble gases. They do not bond. They don't react. Because they're satisfied. Both rules are satisfied. They don't have to make a bond. They don't have to share. They're rich. We got it? That's the last. Everybody else is going to share, do everything they can to get those 8 electrons, whatever it is. There's a couple things they do that we're going to need to know. Now, do you see these things here? They're called periods. So the columns are called groups. The group number, the ones place of the group number tells you the valence shell. You will easily draw a Lewis dot structure if you remember that. That's just how many dots. Just think, how many dots? First, the number one's place of the group number. Are we clear? Okay. So these are telling you the row, the shell. So the first shell only has an S. The second shell has an S and a P. We're only going to worry in this class about the first 2 rows. Are we clear? But in chemistry, you'll worry about all of it. It gets a little more complicated. So a little, not much. So here's the first row and the second row. They're called periods. My God. The kids will find things. You can yawn all you want. That's fine. It's her giggling that's annoying. Oh yeah, absolutely. I do. I mean to do that. I keep meaning to do that. Yes, I will. I'm going to print them. I told the kids in third period or fourth, I can't remember, or fifth. I told them I would print color copies and laminate them this weekend. But if you want, I could print black and white ones today. You like a color? I'm trying to find a real nice, high quality one. Print them at home. I'll have to print 100 of them. I don't mind. And then I'll laminate them all, and then I'll give them to you. Does that sound like a good idea? Maybe we'll wait till the quiz till next week, because I think this is important. I want you to be able to build your models. I don't want you playing with models if you don't know what you're doing. And we're wasting our time. It's not an elementary school class. It's not a preschool class where you're playing with Legos for fun. It is like playing with Legos, but they're very specific Legos that represent bonds. Okay? Now that's strange. So the rows are telling you the shell. Now let's remind you. I'm going to go back and remind you shell. So the first shell is labeled 1. How many electrons can the first shell hold? 2. So it's full with 2. So if the first shell has 2 electrons, it's full. The second shell needs how many? 1, 2, 3, 4, 5, 6, 7, 8. The number 2 here, it's wherever you see 2, it's 2s and 2p. So it can hold 8. Are we clear? If it has 8, it's full. And from then on, if the shell has 8, it's full. All right? I'm telling you, there's a d orbital. We're not going to talk about that. That's for chemistry. We don't have to worry about that, thank goodness. So Lewis dot structure is easy. If you remember those 2 things, those three or 4 things actually, then everything else is easy. If I were going to draw the Lewis dot structure of carbon, I would try carbon with 1, 2, 3, 4. 4 dots. That's carbon. That's a neutral carbon. It needs to make how many bonds? 4. Because it needs 4 because 8 is the number. If I were going to do the Lewis dot structure of hydrogen, what would I have? How many dots? 1. And it's how many, and what shell am I filling in? What shell am I filling in if it's hydrogen? 1, 2, 3. What shell am I filling in? 1. Filling in the first shell, which only holds 2 electrons. Which only holds 2 electrons. So if I have hydrogen, I'm going to put 1 dot. That's hydrogen. How many does this hydrogen need to fill its octet? 2. It needs 1, that's right. But it needs 2. It has 1, needs 1. Well said. So now let's put them together. How could you, these 2 meet in space, carbon and hydrogen floating around in space, and they do. Under the right conditions, carbon meets up with a hydrogen. They're going to share electrons. How many points does it take to make a line? 2. So I'm going to draw a line between them. There's my bond. Now this hydrogen is satisfied. It has 2. When you share, who owns that? Who owns what you share? Your mom and, let's assume I don't know if your parents are married or not or whatever, but my parents, my mother and father, oh, my mom's dead, but my mother and father, I have to remind myself sometimes, I forget. It's hard to remember, and it's sad, but it's hard. So your mom and dad own a home. They share the home. Who owns it? Mom and dad. It belongs to both of them, correct? So These 2 electrons belong to who? Both. So hydrogen has 2 and carbon has these 2. Carbon now has 2, 3, 4, 5. How many does it need? It needs, look, 1, 2, 3, 4, 5. How many does it need total? 8. So it needs to make 3 more bonds. So here comes hydrogen, another hydrogen, another hydrogen, another hydrogen. Oops. This is what you call methane. This is a molecule that you burn every time you turn on your stove. If you have a stove that makes fire, if you don't have an electric stove, you're burning this gas in Cleveland, Ohio. We use methane. It also is the gas that comes out of your butt. That's the gas that makes farts. The smell does not come from methane. The smell comes from the poop that's in your intestines. The gas is methane. The gas is odorless. It has no smell to it. Methane has no smell to it. The gas company has to put the rotten egg smell that you smell. If you ever turn on gas and you don't light it, it smells like rotten eggs. The gas company puts that smell in there so you can know it's happening. Because if it builds up without you knowing, it could blow up, right? Like in the movies, it's very scary, actually. You should be very careful with that. So that's methane. Now, obviously, it doesn't have to bond with another. It doesn't have to bond with hydrogen. It could bond with another carbon. Because each carbon has 4 electrons in its valence shell. How do I know that? Because it's carbon and it's neutral. So it has 4. So here's 1 bond. And then you could put hydrogens on it as well. And it keeps going. Methane, ethane, propane. You've heard of propane? Yes? It's in propane tanks. Some people outside of Cleveland, you'll see these big white tanks outside people's houses. There's propane in them. That's where they get their gas. They don't have methane. They have propane. They just how many carbons you have in the molecule. That's it. Now, we can keep building on these, or you can do something like, let's look at oxygen. How many dots are on oxygen? Let's look at the periodic table. Yes, I will have one for you by Monday. How many dots are on oxygen? 6. See how easy that is? It's easy as long as you remember. It's hard if you forget. 6, just by looking at it, I can tell there's 6. So 1, 2, 3, 4, 5, 6. Did you notice I went around and then I doubled them up only after I filled in every one? I did that on purpose because if they're filling in these orbitals, no. If I'm filling in these orbitals, you're going to fill one here, and then one here, and then you fill out the opposite. They want to be as far away from each other as they can. They don't like to be near each other. So if oxygen is going to make it, how many bonds does oxygen make? Count. How many does it want? It has 6, correct. How many does it want? It wants 8, so it's going to do 2. You're right. It wants 2 more. Correct. To get 8. So if you can do hydrogen again. if you do hydrogen, hydrogen again only has one, but only needs one more. And guess what this is? Look at it. What is it? H2O, which is H2O. 2 hydrogens and an oxygen, which is water. Now, let's, it doesn't have to do it with hydrogen, though. Oxygen could do it with oxygen. Let's see. Oxygen has how many? 1, 2, 3, 4, 5, 6. It's going to do... So if oxygen is going to bind with oxygen, how many bonds is it going to make between them? So there's 2. There's 1. So let's count. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. How can you get 8? Another bond. Let's do another bond. Let's do it. The way we draw this is just simply do that. This is Lewis dot. This is just a line drawing. Most people just like to do the line drawing. See how lazy we are as scientists? We don't want to do all the drawings with all the orbitals and the 3 axes and the placing the electrons. So we get it down to Lewis dot. We find a quick shortcut with the periodic table that tells us how many valence shell electrons. I know we have a cool rule that lets me know I gotta get 8. So all I gotta do is make 2 bonds for so oxygen gas. This is the oxygen you breathe, by the way. This is the oxygen you breathe. It's O2. There's oxygen in water. Can you breathe the oxygen in water? Can you use that oxygen? No, you cannot. Fish don't either, by the way. They don't breathe water. They don't use the water. They get the oxygen out of the water. There's oxygen in water, and they get the oxygen gas out of the water. They breathe in. They pull the water in through their gills, and the water goes over their gills, and oxygen diffuses through. You don't know this word diffuse yet, but you'll understand it when we go through diffusion. The oxygen goes from the water into their blood. It's very similar to what we do, except we pull in air, and we get the oxygen out of air. They have their blood, their system set up so they can pull oxygen out when it's only a very tiny bit. They can't pull air in through their gills. They can't do it. So if you ever pull a fish out of water, you'll see their little gills going like this, trying to breathe. They're suffocating. You want to get them back in the water as soon as you can. Unless you're going to eat them. All right, so people eat fish. All right, whatever. So oxygen gas. Liquid, it's water, can be liquid, can be gas, but at room temperature it's liquid. We usually put an L. Oxygen at room temperature tends to be a gas, so we put a G at room temperature and 1 atmosphere pressure. Again, gas and liquid can change depending on the temperature and the pressure. All right, so that's oxygen gas. We've used these bonding rules to make a lot of molecules so far. By the way, this is a molecule. It's the only thing that's a molecule. When things are sharing electrons, it's all there is. There is no other kind of molecule. A molecule is, well, there are different kinds of molecules, but there are different kinds of sharing, but if they're not sharing, it's not a molecule. Is that clear? All right. So, yeah.
In the blue, is that an L?
That's an L. That's a cursive L. In the blue, that's a cursive L. That's how they'll draw it in a book. That's how they draw it in chemistry books and biology books. So I'm going to draw it that way here. They're not going to put a little stick. You put a stick, guys, and you know this when you're trying to do passwords. You put a stick for a little lowercase l. Is it a 1? Is it a stick? You put an O. You know this from passwords. Is it an O? Is it a 0? I can't tell, right? So to be clear, they do a little fancy cursive L. All right. So that's what you're going to, so on Monday, what I'm going to do is I'm going to give you a bunch of different balls. Go ahead, get it out. All right, so I'm going to give you a bunch of different balls. One will be able to make 4 bonds. It'll have 4 little clippy things you can make 4 bonds to. One will be bigger, and you'll be able to make only 2 bonds. And one will be small and can only make 1 bond. What do you think these things are? 4 bonds, what do you think it is, considering what we've been talking about? The one that can make 4 bonds, what do you think? Which element do you think it is? Carbon. It'll be carbon. The one that can only make 2 bonds, which one do you think it is? Oxygen. And the one that can only make 1 bond, what do you think it is? Hydrogen. So you're going to get these 3, and you're going to make sugar, you're going to make proteins, you're going to make lipids. It'll be fun. That's what we're going to do on Monday and Tuesday next week.